In the last tab, we're asked to conduct a simple linear regression in order to predict the number of passengers based on the length of the ship. If you scroll down a little bit, you can see the data set. So in order to run a regression analysis, I'm going to open up the data analysis tool pack, and I am going to select regression. First, we have to indicate what the y variable is. Again, the y variable is the variable that you want to predict or estimate. In our case, that's number of passengers. So I'm going to select that entire column, including the heading. The x variable is the variable that we're using to predict y. So we're going to use length to predict the number of passengers. So I'm going to select that column, including the heading. I want my labels box checked, and that's because I included the headings. And then again, for the output range, we're going to select that designated cell. And then if you click OK, OK again, here is the output for the regression equation. And the very first thing you want to do is the global test. So the global test tells you if at least one x variable predicts y. In our case, we only have one x variable, so the global test is basically telling us if length predicts the number of passengers. If you look at the p-value, you can see that it has an e-53 in it. This is scientific notation. This e-53 is telling you that you need to move the decimal place over 53 places. So the actual number would be 0.000, 52 zeros, and then 294. So this is a very small number. Anytime you have a p-value that's less than 0.001, we report it as less than 0.001. So again, the cutoff for the global test is that if the p-value is equal to or less than 0.05, that means your at least one x variable predicts y, and that is the case. Our p-value is less than 0.05, so that means our x variable length predicts number of passengers. And if you go down to the p-value for the individual test for length, you can see that it is the same. And again, this is always going to be the case for simple linear regression when you just have one x variable. So we can conclude that length can be used to predict the number of passengers. So now I can start to answer my questions. What is the p-value for the global test? I'm going to type in less than 0.001. I'm not going to reference it, again, because it's less than 0.001. We don't want to type in a p-value of 0 or indicate a p-value of 0. Whenever you do this, make sure that you're very careful to have a space between the less than sign and then the dot. So our grading program is really sensitive. If you didn't include that space, it would mark it as wrong. And then for number 3, we can say yes. We can use length to predict passenger capacity. The next question asks for the regression equation. So now we can do that. We can put together the regression equation. So if you remember the regression equation, the purpose of it is that we're trying to predict the number of passengers. So predicted number of passengers. And it would be our slope, so that would be 4.77, times our x variable, which is length, plus the y-intercept, which is negative 20.30. So since it's negative, I'm just going to do minus 20.30. So that is our regression equation. Now if we know the length of a cruise ship, we can just plug it into the equation, and then we can predict the number of passengers that it can hold. If you go back up to the questions, you can see C is our regression equation. So I'm going to pick C. Next, I'm going to want to complete the model summary table. So I'm just going to reference the appropriate cells in my output. So the intercept, again, is negative 20.30. The slope for the length is 4.77. And again, for the p-value, I'm not going to reference it because it's less than 0.001. So I'm going to do less than space 0.001. Now we can use our regression equation to predict the number of passengers. So that would be equals the intercept, locked, plus the slope, locked, times the length. here you can see the estimated number of passengers. So you can see that these are the estimated number of passengers for each ship, and we base that on the length of the ship. And keep in mind that this data is in hundreds. Now I want to talk about error associated with the regression equation. So when we use the regression equation, we're not getting 100% accurate estimations. So for the first ship, we estimated that they would have about 1,300 passengers. This is somewhat of a rough estimate. We're not going to be 100% accurate. So there's always some degree of error associated with any regression analysis. Another term for error is residual, and residual is the difference between y and y hat, or in other words, it's the difference between the observed or the actual y value and the predicted y value. Here is a visual depiction of error. So if you focus on this dot right here, this is a restaurant, and they had roughly about 1,450 website hits. And then their revenue, what their revenue actually was, what their observed revenue was about 11,500. But if you look at the regression line, this is the regression equation, this restaurant was predicted to have about $13,000 in revenue. So the difference between the observed revenue and the predicted revenue is error. You can see for some restaurants, the regression equation did a really good job of estimating revenue. So these two restaurants here, their actual revenue was pretty much the same as what their regression equation predicted it would be. For other restaurants, there's more error. So if you look at this restaurant right here, there's a lot of error associated with this prediction. So the regression equation predicted that it would have about 12,500 in weekly revenue, but it actually only had 10,000. So this prediction's associated with more error. There's a couple of statistics that you can look at in order to get an idea of how much error is associated with your particular regression analysis. One that I really like is called the standard error of the estimate. So this tells us the average difference between y and y hat, or the average difference between observed scores and their predicted values. And ideally we want this to be as small as possible. So you want your standard error of the estimate to be as small as possible. If you return to your prep file, you can see that the model summary table asks us for the standard error. So I'm going to reference that cell in the output. And here is our standard error, 4.55. What this number is telling us is that on average, the actual number of passengers will differ from the predicted number of passengers by 4.55 or 455. Another statistic that we can compute is the 95% prediction interval. This is an interval or range in which we are 95% confident that the actual value of y will be included in. To compute the lower limit of the range, you take y hat minus 2 times the standard error. To compute the upper limit, or the upper range, you take y hat plus 2 times the standard error. If you return to your prediction table, you can see that we're going to compute the lower and the upper limit for the prediction interval. So for the lower limit, again, it's y hat, or the estimated number of passengers, minus 2 times the standard error. And I'm going to lock the standard error. Copy it down. For the upper limit, again, it's y hat, or estimated number of passengers, plus 2 times the standard error. Again, the 95% prediction interval is an interval or range in which we are 95% confident the actual value of y is. So for the first cruise ship, the regression equation estimated that the number of passengers would be 13.07. And what the prediction interval is telling us is that we're 95% confident that the actual number of passengers will be between 3.97 and 22.16. For the second cruise ship, we are 95% confident that the actual number of passengers is going to be between 8.74 and 26.93. The last statistic I'm going to talk about is R squared. R squared is the correlation coefficient squared. And once you square the correlation coefficient, it provides useful information. So it tells us the percentage of the variance in Y that can be explained by the variance in X. And this might sound a little bit complicated, but really what that means is it's telling us the percentage of differences in Y that can be explained by the differences in X. We want our R squared to be big. So the bigger it is, the more accurately we can predict Y. If you look at your prep file, you can see that question number 5 asks for R squared. So I am going to reference that cell in the output. So if you go down to the output, you can see here it is, 0.78 or 78.06%. So what this value is telling us is it's telling us that 78% of the differences in cruise ships in terms of their passenger capacity is due to their differences in length. And if you look at question number 6, you can see that it's saying the same thing. So question number 6 is giving the definition of R squared. So that answer is 0.7806. I'm just going to type it in. And then what I'm going to do is I'm going to change it to percentage. Question number 7 asks about the standard error of the estimate. We already did that, so I'm going to just reference that again. I'm referencing it in the model summary table. And then the very last question asks, on average, how much will the predicted number of passengers differ from the actual number of passengers? And this is the definition of the standard error. So it's basically asking us what the standard error is. So it's 4.55. I'm going to type that in. And that's it for this prep assignment.